Okay, and we're back. So today we're doing section 2.8, graphing linear and absolute value inequalities. Today's objectives are to graph linear inequalities and to also graph absolute value inequalities. Our vocabulary is going to be linear inequality and boundary. So before we get too much further, we need to identify solid or dashed lines. So inequalities that have either a less than or greater than sign will have a dashed line for their graphs. These symbols do not include the actual line. We're going to find out more about this in the future, but there's going to be a whole region that is the answer, a whole huge area of the graph, and it's going to be that entire region up to but not including the line. Whereas when we have inequalities that have a less than or equal to or a greater than or equal to sign, they will have a solid line. These symbols do actually include the line. All right, let's go ahead and get started. It's going to be a fast one today, folks. All right, so the first thing we're going to do is we're going to graph x plus 4y greater than 2. Well, the first thing I want to do here is I want to get this into my slope-intercept form because that is by far the easiest way to graph these things. All right, so what do? Well, first thing we have to do is we have to subtract x from both sides. And we will get a 4y is greater than negative x plus 2. Let's zoom in a bit. There we go. So the next thing we want to do here is we need to divide everything by 4. So I'm dividing by 4, dividing by 4, dividing by 4, and we get y is... Now, I know we've had some issues with this in the past, but here we have a negative being divided by 4. We're not actually dividing something by a negative. We're actually dividing by a positive. So we're going to leave the sign exactly how it is. We're going to get y is greater than negative 1/4 x, so that's our slope, plus a 1/2. Well, that kind of sucks. We have a fraction. Oh well. Let's do this. Okay. So we now have this in our slope-intercept form. We don't have an equation, we have an inequality, but we're going to graph it very similar to if it were just an equation. So we'll get these out here, and we'll go ahead and graph our x and our y intercept. So I'm going to change this a little bit. And I'm going to say that each of these squares is 2. And the reason why I'm going to do this, so this will be each 2 squares is 1. So that'll be 1, that'll be 2, and this will be 3. So then this will be 1. This will be 2, this will be 3, and this will be 4. So the reason why I'm doing this is because we have that y-intercept of 1/2. And, well, that's not very nice. So I just want to be sure to graph this so that way we don't have to kind of approximate everything. We can at least put it on a checkered grid. So that means that if I do this, our y-intercept will be a 1/2. I know it's 1 up, but if we recall, up here is actually positive 1, so we're just halfway. And then from here, it'll be easier to count our slope of down by 1 and over by 4. So I'm going to, for now, use a highlighter. I'm going to say, okay, well, that is down by 1 because we're at a positive half. Now we're at a negative half, so we went down by 1. Then we have to go over by 4. I'm not going to highlight that part, but let me go ahead and do that. So we're going to, down by 1, over by 4. We're just right over here. Let me change my eraser real fast. You can't see. That's okay. All right, so now what I'm going to do is I'm going to connect the dots with a line. Oops, that was the eraser. So I'm connecting these with a line. A little bit went to that equation. Apologies. I'm going to try to get the line to go the other direction also. Okay, good enough. All right. So the first thing we have here, which I need to point out, is that we have the greater than sign, but there's no equals to. So we actually need to make this a dashed line. So I'm going to go through, and I'm going to put little dashes in our line. So that way, oops, I got rid of a little bit of the black there. So that way we can see that there's actually holes in this line. It's not a solid line. It's not going on forever and ever and ever. Well, it is, but we're not including the actual line. Yeah, a little black there also. Okay, there we go. All right, so the next thing here is we're going to need to we need to shade. We need to either shade above the line or we need to shade below the line. For those of us who might see it, this right here is saying that y is greater than, and then if you can identify this part is the line. So y is greater than that. So that's going to tell me that we're going to need to shade above this line. So I'm gonna do that right now. But we're going to actually do some math for those of us who don't see that. So that way we can at least, compute what side to shade. And I should increase the size of my highlighter before I do any more examples. Okay, there we go. So I'm saying we're going to shade this part. Now, how did we know that if we weren't able to see what I was trying to point out there? Well, we could take our line, our y is greater than negative 1/4 x plus 1/2, and we can get a test point. We can pick any point on the graph. It doesn't matter where it is. I always suggest, if the line doesn't go over the point, to use 0, 0. It's a nice number. I always suggest pick a number which is the same for the x and the y. So here's what I'm calling my test points. And what I'm going to do is I'm going to take that test point and I'm going to plug it into the equation. Our x is a 0, so we're going to get, let's see, negative 1/4 times 0 plus 1/2. Our y is a 0, and we'll just simplify. Is 0 greater than, let's see, negative 1/4 times 0 is 0. Okay. 1/2. Is 0 greater than 1/2? No, that's false. Since that's false, what we need to do is we need to shade the side of the graph which does not include the test points, which, well, we just did. That was this part here. So right there we found two different ways to determine where it's a graph. We could either read the equation, which might not be the easiest thing to do, and shade areas from there, or we could put a test point in there and find out whether it's true or false. If it was true, we would have shaded the point with the dots. If it's false, we shade the point on the opposite side of the dot. All right. So that was our example 1. Look, we're already on slide 5 of 7, folks. We're almost there. All right. Another line, graph, 6x minus 2y is greater than 8. We're going to start off very much the same here. We're going to go ahead and get y by itself. So I'll subtract 6x from both sides. We'll get a negative 2y is greater than or equal to negative 6x plus 8. We're going to divide by a negative 2 this time. So last time we didn't divide by a negative, so the sign stayed the same. This time we are dividing by a negative, so we need to flip the sign and then get a y is less than or equal to a 3x minus 4. Okay, cool. No fractions. This should make the graphing a little bit easier. Let's give that a shot. All right, so we have a negative y-intercept, and we have a positive slope. So I'm going to go ahead and I'm going to kind of make my x-intercept be a little bit higher here. I'll make it towards the center. There we go. And I'll make these lines bolder so it's harder to see that I kind of missed. All right, so first off, we'll start with our y-intercept, which is the -4. So I'm going to go down 1, 2, 3, 4, and make a dot. Our slope, in case we didn't see it last time, our m is equal to a 3, which is a 3 over 1. We can always change it to a fraction. So we're going to go up by 3 and over by 1. So up 1, 2, 3, over by 1. Up by 1, 2, 3, over by 1. It wasn't as easy to do it last time because we had those fractions, but now it's fairly straightforward. Then we'll connect all the dots here. There we go. Then I'll try to do the same on the other side. There we go. And then I ask, which you can't answer because this is a YouTube video, do we need to make this solid or dashed? Do we need to erase little holes into the lines? Well, if we look over here, and yes, now I'm going to actually make my highlighter larger. If we look over here, it's got the equals to. Since it has the equals to, we can go ahead and just we can shade, we can leave it solid. Okay, so now the next question is, do we shade the left of this line or the right of this line? Well, I see, so once again, I'm looking at this, it says y is less than, and I'm trying to think of this as water, all right? If I had water and I were to pour it onto this side of the graph, would there be water on top of the line or would there be water below the line? Well, in this case, the water is going to fall straight down and it's going to actually hit the line and then it'll start to run down the side. So that's actually the top of the line. So that would be y is greater than, which is not what we're doing. We're going to be doing the y is less than, but let's go ahead and test that out. Well, I guess that's as big as my highlighter gets. I wish it would have gotten larger. All right, I'm not doing a great job of shading, but that's okay. And good enough. Okay. Let's test it. So what's a good test point? So last time I did 0, 0, which is fine. I'm going to try something else here. I'm going to try 1, 1, which is right here. All right. I like it to be the same number both times, the same number for the x as well as the y, so that way we don't, you know, on a test or a quiz, get all frantic and be like, oh my goodness, I plugged them into the wrong one. Nope, it's the same number, doesn't matter. Okay, so is 1 less than or equal to 3 times 1 minus 4? Is 1 less than or equal to 3 minus 4? Or is 1 less than or equal to -1? And that, again, is false. So that's why we want to shade the other side of the line. Okay, yes, so we're going to want to shade the other side. So that's the algebraic way of showing where we'd want to shade. All right, last example, we're going to have an absolute value function here. Luckily, it's in its nicest possible form. So let's go ahead and just get started. All right, make my grids. So if we recall from our transformation of functions lesson, that we have a vertical shift of down by 4. And if we recall from our absolute values lesson, we just have a slope of positive or -1. So we'll start doing this. We'll do our shift downwards of 4. So that's going to be 1, 2, 3, 4. So that's going to be the tip of our V. And then we need to have a slope of 1. So that'll be these points right here, and I'm going to go ahead and connect those dots because that's a fairly straightforward one. Then we also need to have a slope of -1, which ideally is just a mirror of what we just had done. So there's 2 more dots, mirroring on the other side. And there we go. Now we ask ourselves, is this a solid or a dashed line? Well, looking at it, we have the equals to, so it has to be a solid line. The next question is, are we going to shade above the V or below the V? For those of us who can see it again, it says y is greater than, which means we want to shade above it. But before I shade, let's go ahead and just test some stuff out. Let's see. So I haven't done a negative negative, so let's do a -1, -1. So I'm just doing different test points. You can pick whatever you want, which is not actually on the line. In this case, my pink lines. All right. So we're going to get that's the eraser, -1 greater than or equal to the absolute value of -1 minus 4. Let's make those absolute values a little bit longer. Okay. So we get -1 greater than or equal to, the absolute value just makes it positive, 1 minus 4. Or -1 is greater than or equal to -3, and that is in fact true. So this time we're actually going to shade the area with the dots. Let me go ahead and make my highlighter larger because we have a lot to shade here. And there we go, we're shading that whole area. All right, folks, that was the lesson. Hopefully with our earlier skills, this wasn't too difficult. If it was, well, the good news is we have a video, we can watch it, we can do more of this. All right, see you in class.